In the heart of knowledge, where dreams take flight, lies a realm of endless possibilities. At UTEM, the future unfolds with every step you take, where minds are molded and destinies shaped. Embark on a journey where innovation dances with tradition, and every dawn brings new horizons.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imam Abdul Razak. My metric number is B1123102001. So I will be explaining about the introduction and methodology. After that, I will be answering the question 1C and D. So for the introduction, ANOVA and regression analysis are fundamental statistical method used to investigate and comprehend data. So ANOVA is a statistical method used to compare the means of three or more groups in order to determine whether they are significant difference. It does this by analyzing the total variance and breaking it down into several components. The analysis examines the variation within each group and between various groups. Use the F statistic to ascertain the significance of these discrepancies. For regression analysis is used to describe the connection between a dependent variable and one or more independent variable. Linear regression is the most often used method of analysis that calculate coefficient for each independent variable and demonstrate their influence on the dependent variable. Next, we move to the methodology. So the methodology of ANOVA, firstly, we need to define the hypothesis. Then we calculate the group mean and overall mean. After that, we calculate the sum of square. Then we compute the mean square. And then we calculate the F statistic. And lastly, we determine the p-value. So for the regression methodology, firstly, we need to define the model. Then we estimate the parameter. After that, we assess the model fit. Then we evaluate the assumption. After that, we do the hypothesis testing, and then we diagnostic checks, and lastly, we do the prediction and interpretation. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imam Abdul Razak. My metric number is B1123102001. So I will be answering question 1C and D. So as you can see, this is table of data that I sort from raw data. The table titled is the world electricity consumption from energy source from 1985 to until 2021. So there is 10 treatment here. So the treatment is type of energy. So from this data, I run the ANOVA test. So I run the ANOVA test from this data analysis. So I choose the ANOVA single factor, and the input range is I choose all this data, and then I get this ANOVA table. So the first the first test at alpha 0.05. So we got the summary group. The groups is all the treatment. So the count, sum, average, and variance we get. Then the ANOVA table. So this is SSA, SSE, SST, MSA, MSE, and F test. Also we get the F critical. So the F test I get is 162.5723, and F critical is 1.9059. So the F test is larger than F critical. So it's reject hash node. So the conclusion is the world electricity consumption from 10 type of energy source is different. So after that, I ran the ANOVA test for the second time at alpha 0.02. So the summary group count, sum, average, variance are all the same as before. And we get the ANOVA table. So the SS, MS, and F test also the same, but the F critical is different. So the F test I get is 162.5723, and the F critical is 2.2253. So the F test is larger than F critical and is rejection. So the conclusion is the world electricity consumption from 10 type of energy source is different. Uh, so based on the two ANOVA tests, even though the value of significant value alpha change, the value of F test is larger than F critical value. So this show that the world electricity consumption from energy source is significantly different for a year from 1985 until 2021. Then I run the t-test for PET two sample for mean. So that's mean it needs two variable to run this test. So how I run this test, I choose the data analysis also. So then I choose the t-test PET two sample for mean. And the variable one is cold electricity. And variable two is the fossil electricity. Then I get this table. So I state the null hypothesis and alternative hypothesis. For the null hypothesis is mu1 equal to mu2, and the alternative hypothesis is mu1 not equal to mu2. So the t-test I get from this test is negative 18.89998, and the t-critical is 1.6883. So the t-test is smaller than the t-critical and is at set hash node. And the conclusion is there is no difference between the mean of type of energy. And I run the t-test for the second time at also at alpha 0.05. So, but the variable is different. So I use the same cold electricity, but the different at the fossil electricity and gas electricity. So for this second time run t-test, I use gas electricity. So the null hypothesis and the alternative hypothesis is the same as before. So the t-test I get is 38.8205 and the t-critical is 1.6883. So the t-test is larger than t-critical, so it's reject H naught. So the conclusion is there is difference between the mean of type of energy. So that's all from me. Thank you.
Hi, my name is AFIQAH binti SHAHDAN. As we can see, this is the raw data that have been collected from the KAGA website. It's about the electricity consumption from the energy source. But we have been decided to take only 37 years from the 1985 to 2021 only. And the data have shown 10 different type of energy source and had 370 sample have been collected, and after that we have to find the central tendency, which is mean, median and mode. But we only have find the mean and median, but the mode we don't use because our data don't have the repeated number. Then we have the variance and standard deviation and the counts. Okay, next we will see the shape of distribution data every 5 years from the data. We can assume that the fossil fuel has consistently dominated the global electricity consumption with the significant growth. Overall, there is noticeable inclination toward the expanding and variety of the energy source, with the particular focus on promoting low carbon and renewable energy.
Hello, my name is Adelaide Angela QI'UNG, and today I'll be explaining about the graph that we got from our data collection. So this is the graph for the world electricity consumption from energy source from the year 1985 to 2021. So as you can see, mostly all of the types of electricity in energy source that consume electricity increase. They barely decreases throughout the year, and now for and here is the pie chart obtained from our data intake. So this is a total type of energy source, and as you can see, these are the percentage of how much it consumes energy. electricity. For the most, as you can see here, is fossil electricity, like how the graph showed earlier. Look at how the consumption for fossil electricity is, and then here is the pie chart for that. And the least used energy source is a solar electricity. That's all from me.
Hi, my name is FREDDA and KASAN, and my metric number is B11231010. So this is our assignment for engineering statistics, and I will answer for question 2 and explain for A, B, C, and D. As you can see here, question 2 wants us to using multiple regression analysis in an appropriate software. So I've been choosing Excel because I think it is an appropriate software. Okay. So for part A, we have to make a Google form. For part B, we have to extract the data from the Google form into Excel. And for part C and D, we have to make a scatter plot. But for part C, we have to make a scatter plot between dependent and independent. And part D, we have to make a scatter plot of multicollinearity, which is between all the independent variables. So this is the question that I have provided for student attempt to answer, which is I already make a explanation about dependent variable is the GPA, and the independent variable is how many hours you sleep per day, what is your family income, how many hours do you spend on study, and how many hours do you spend on exercise per week. So all of the responses will come out here, and we can extract the data of the responses into the Excel sheets like this. So I've already key in all of the data here like this. Okay, as you can see, for question C, they want us to make a scatter plot. Okay, so you have to select the data that you want, but make sure it is between independent variable and dependent variable. So after you select the data, make sure to click the scatter. Okay, the scatter like this. But as you can see here, the dependent variable is at the x-axis. It's wrong, alright? So you have to select data and edit, and x value, make sure the x value is our independent variable, and the y value is our dependent variable. Okay, so this is the right scatter plot. So here we don't have the linear regression. So if we want to see the linear regression, we go to the trend line and put linear. Okay, we can make it bold like this. Okay, so after that, we have to calculate the correlation coefficient. So if you want to calculate the correlation coefficient, you just have to click this fx, which is function, go to Corel function, and the area one is our independent variable. Okay, our independent variable, and our area 2 is dependent variable. So after that, you will get the data for correlation coefficient and change it into number and get the 4 decimal places. As you can see here, it is 0.043. So it is bad because it is a weak linear correlation. Okay, and it is for first independent variable, which is sleep duration. I've already make it into like this. Okay, so this is the scatter plot for dependent and independent variable, while this is the scatter plot for multicollinearity. So in this part, we have to make a relationship between independent variable only. So all of the scatter plot and all of the correlation coefficient is a weak linear correlation, indicate that none of the independent variable have a strong linear relation with GPA. Alright? Okay. So if you want to make a regression data, you have to go for the data and then data analysis. Okay, data analysis. where is the data analysis? Okay, regression, go for regression and click input where range is our GPA and our X is independent variable, all of the independent variable. Just get it in like this, click levels, output range, where you want to put the data, click OK. So if you don't want to see the many numbers like this, just click number, and this is your regression data. All right. Okay. Thank you. That is all from me.
Hi, my name is FREDDA SAMANTHA and KASSIM, and I'm going to explain about question E, F, G, and H. Okay, so for E, I will interpret about the estimated regression equation, which is this one. Y equal to constant plus B1 x1 plus B2 x2 plus B3 x3 and plus B4 x4. So Y represents GPA, constants represent intercept here, B1 represent sleep durations times with estimate sleep duration in hours, plus B2 is family income times with estimate family income in ringgit Malaysia, plus study hours times with estimate study hours, and then the last one is plus with exercise duration per week times with exercise duration per week. Okay, so here we already calculate the estimated regression, which is 3.04. As here we get the 3.04 because for the sleep duration we times by 6, and then the family income we times by 4,500 ringgit, and then the study hours we times by 5 hours, and then the exercise duration per week we times by 4 hours. So it equal to 3.04. Okay, next is we interpret about coefficients, which is coefficient is basically we can call it as sine of R, which is when a value is close to 1, it indicates a strong positive linear relationship. And when the value is close to -1, it indicates a strong negative linear relationship. So in this case, the value here is 2.828, which is close to 1, and it have a strong positive linear relationship. Coefficients basically explain about the average expected change in the explanatory variable remains constant. For example, for each additional hour of sleep durations, the GPA is expected to increase by 0.012. Assuming other variables here, for example, family income, study hours, and exercise duration per week, remain constant. So we can interpret the coefficients for the intercept to mean that the expected GPA for a student who have 0 hours for sleep and study, 0 family income, and 0 durations for exercise is 2.828 in total. Then next is the p-value, which is the individual p-value tell us whether or not each explanatory variable is statistically significant. We can see that the sleep duration here is 0.793, family income is 0.203, and then the study hours is 0.673, and then the last one is exercise during per week is 0.914, which all variables is not statistically significant at alpha equal to 0.05. Okay, next we go to regression statistic, this part, which is multiple R is 0.236. It represents the multiple correlation between the response variable and 4 predictor variables. And then the R square is 0.056, known as coefficient of determination. Based on the result, 6%, we can change this, 6% of the variation in the GPA can be explained by the hours of sleep durations, family income, study hours, and duration of exercise per week. Okay, and then the adjusted R squared is equal to negative 0.052, represent the R square value adjusted for the number of predicted variables in the model. And the standard error is 0.452. Is the average distance that the observed values fall from the regression line. In this result, the observed values falls on average of 0.452 units from the regression line. And then the last one is observations, which is 40, is the total sample size of the data set used to produce the regression model. Okay, so now we're going to the conclusion. which is this part. So this is the, as we can see, this is the test statistic, which is negative 6.943. And then this is the critical t-value for one tel, which is 1.665. And then this one is for the two tel, 1.992. The p-value for both tel is 0.000, because the probability of observing at t statistic, which is negative 6.943, as extreme as negative or more extreme in either direction under null hypothesis is essentially 0. Since the absolute value of the observed t statistic is 6.943, is larger than critical t-value for both one tel and two tel, and the p-value is smaller than the significant level, which is just now alpha 0.05. So for this data that we get, we finally conclude that the null hypothesis is rejected. Yes, thank you. That's all from me.
Join us at UTEM, where the pursuit of wisdom weaves a tapestry of success. Become a part of a legacy that transcends time, and let your story be written in the stars. Enroll today, and let your brilliance illuminate the world.